Good day, everyone. So we are going to be introducing ourselves to data engineering, very basic aspect of data engineering, using Docker and Postgres for basic data pipeline. In a simple term, what data engineering actually entails is getting data from one source, performing some kind of task on the data, and saving it to another secondary source for use. So we are going to be looking at a particular data set in CSV, then we are going to move it into Postgres database in a way that it can easily be reused in case maybe the data has changed or it has increased in size. And you can build on the process we are going to use to do similar things. So this is a part of the homework for Data Engineering Zoom Camp by Data Talk Club. I'm going to share the link in the description. So if you want to kickstart your data engineering career, it is a good place to start with a very rigorous 6-week guided tutorials and then practice so that you can get hands-on practice. So let's go straight to action. Basically, I will be jumping some steps, but I'm going to tell you how my system is currently set up. We are going to be using Docker and Postgres. So to get Docker, I'm currently running a Windows system. To get Docker, you need to use a Docker desktop. Also, I'm using the WSL Linux distribution for Windows. So I'm connecting the Ubuntu on my system with Docker Desktop. That is my setup. So I'm going to show you every other tools that will be used. Then we'll kickstart the journey. So if you want to know about WSL, you can come to this official site to read about it and install it on your system. Then also for Windows user, you can easily install Docker Desktop just like the way you install every other application. So the database we'll be using is this open source database PostgreSQL, and you can use it. It's very powerful. But, to have access to your data in a visual way, we are going to be using pgadmin. Pgadmin is just a way to visualize your data, see different action. Then you can actually write query on them. So if you want to learn about Docker, Docker is very wide, but for this, we are going to be using Docker Compose. Docker Compose make it easy for us to set up different things we need for our project in a single file. And the file is normally having YAML extension. So you can set up your Postgres admin, the software that you might have installed separately before. You can set it up. You can also set up your database, actually PG database, the Postgres database. You can set it up with it. Then you install PG admin 2 on the same thing. Then you just run in and you can kickstart. So because we are going to be using Python for our intermediary processing, we are going to need some things. We are going to need this extension, cycle, I don't know how to pronounce that, but basically what it is used for is an adapter to work between Python and Postgres. So it helps you understand Python datasets or uh, anyhow you want to call it, to create a link between Python related arrays and the likes with database. And you know we are going to be using Postgres, so we are going to focus on that, how to convert data structures in Python into what Postgres will understand. Then also to connect our Python code to the database, we are going to be using SQL Alchemy. It is very good also. It just form like a relational mapper. So you just run one single code and you have your data sets in your database. Then if you don't want to go through a lot of setup, you can install Anaconda. It has most of this installed. I think this is just what you need to add to it, but if it is not available, you can just install it individually. Then the data set we'll be using is from New York City open database related to taxi, and we are going to be focusing on 2019 green taxi trip records data. So currently they are using this file packet, or we were going to be using the backup file provided by Data Engineering Zoom Camp for the practice. So basically, if you can get all this set up, you can join me in doing the process. It's part of the homework. I just decided to do a screen recording for it. But if you want the full details on how to get all this set up by yourself, you can check the Data Engineering Zoom Camp and you will be able to do all those yourself from the introduction that requires the setups and everything. So let's start. So the first thing we are going to be doing is to use Terminal. There's this new window Terminal if you are using or if you have installed it. To use Terminal to access our Ubuntu setup and create a folder, then download the files we are going to be using. So in this terminal, you can open multiple. So you can see I have the Ubuntu 2022 LTS version. So I have a folder for the Zoom camp. So I'm going to do it here. So let's say we want to do it in homework folder. So we can go to the homework folder. Then what we need to do is to get the two files that we need. We actually need two files. We'll use one just for this recording. So I've put the link down here. This is the link to the backup CSV file. So if you need that, you can. I'll put it in the comments. So for me, we can just do with this. And if you can also just paste it directly and you get it. This is the zone file. We need a main data set that is larger than that. That's just showing the zone. We are going to take a sneak peek into them when we start the Python script. So now I'm going to download the other one. This one might take some time because of my slow network, but it's fast. So we can check what we have now. So we have the two files. So the next thing we can do is to try and see what the files look like. And to do that, I have an Anaconda. You can see it will bring us support. So I can easily start a Jupyter notebook and take a look at the content of the files. So let's wait. So I'll create a new notebook, and to look at the content, we can use pandas to read the file. Then I can do pd read. So that I get the name of the file, I can quickly do this. Then let's see. pd read. Because the file is very large, I'm going to just look at 100 rows out of the file. Then we can see green drips data file. So let's look at it. And so you can see we have all of this data. They are quite large. It should be in the millions also, like a million plus. So we are going to find a way to convert it and put it into our database. The other thing we can do is to check for the other one. So I'm just going to use the same thing, but just change it soon. So this one is not large, so we can read everything we have inside. So I'll just read everything and check. So there's a T missing. Yes, we have it. We can check the size of this, and you see it's just 265. So because we are going to need to connect to the database, so it's better we set up our database file using Docker Compose, then get everything up and running. So to do that, I've already set it up before, so I'm just going to guide you through how the Docker Compose file work and the content and what each of the configuration means. So, okay, so to set up our Docker with Docker Compose, PG Database, and PG Admin, we're going to start a new terminal and go inside our folder. So we have this file. So the Docker Compose file, you have to create it, and we said it normally have this extension. So we can now go inside and try to edit it. So like I've said, I already have it set up before. I'm just going to walk you through. So we are installing two services, as we said, PG Database and PG Admin. This is the main database. You can access it through CLI or anything you have, but we want a visual way to easily click and have more functionality. So we'll be installing PG Admin also. So for the PG database, just like every package is in package manager in different programming languages, we need to specify an image instead of a package. We specify an image, and the image we want is Postgres and version 13. Then we set the environmental variable. For this, we only need these three environmental variables: the database user, password, and the database name. So we just set it like this. I kept my own very simple. You can make it, but since it's local setup, you can just write basic thing. Then this volume is to make sure that anytime we restart this container, it should persist. It should keep the record we have inside before and still bring it back. So for me, I'm saving the record here in this folder on my Ubuntu, that is on my system, and this is the folder that is going to be on the virtual machine. So this RW simply means read and write. It's the default setting. That means you can actually remove it if you want. Then for database, we need ports. So the default port for Postgres is 5432. So we just map it to the same kind of ports. Then for the PG admin, the first service is PG database. We are done with that block. The next one is PG admin. The image for that one, this is the name. You get it from Docker repository. That's just the name. Then environment variable we need for this one. We need a way to be able to log into the PG admin. So we give it the default email and the default password. Again, so that the record will persist, the setting, the configuration, everything. We have to do this. This is the folder on the virtual machine on the Docker, what it will start, and this is the folder that will keep on our system. Basically, what we are doing is anything we are doing while we are in the virtual machine, there will be a copy in our own folder locally. So that when we start it again, the virtual machine can pick it up from there and continue. Then for that, we use port 8080 and map it to 80. So to see this in action, we have to go back to our terminal and run docker compose with an hyphen. Then we say it should come up. So because me, I have some of the container, some of the image is already downloaded, it will be fast. But if it is your first time, it might take some time, and maybe you might see some bugs that you have to toggle based on your system. Different system can bring up different issue. But for me, I've been able to do that, and I've given you the link where you can see all those. So if you check our Docker now, you'll see we have two things running, the Postgres and we can actually see them in the browser. So you can see, we can log in and check. So now we have the database and we have the way to visually see our data. The next step would be to now format the CSV data we have, and we format it in a way that we can now push it into what? The database, and that is the end of the data engineering pipeline for this basic introduction. So we are going to go back to our Jupyter notebook and continue writing our code so that it can read all of the rows in the dataset and put it inside pgadmin. Now we can try to connect to the database we create. So to do that, we need to import create engine, and it is inside the library I said we are going to use SQL Alchemy. So basically, we are going to use this to create an engine, just a way to connect to the database. So the format is, we save it in a variable, we have create engine. Then we need our user, our password, then the hosts, and finally we need our database. There's something missing. We need to put the ports also. So to make it easier to edit, we are going to make them into variable. Our user, we set it to root. The password is also root, and we have the hosts to be the default host, which is localhost. We can easily use localhost because we are using Docker Compose. If we had run the instances differently, we have to create a network. But that's for another day. Then the next thing is we need the ports. The port is default to 5432, and the database we are using is still NY taxi. This is the same configuration we had in our composer file. So next, to make this work, we'll try that. So let's try it now. Name error, create engine, that's spelling. So you see we have it, but to actually connect to the database, we need to call a method, which is connect. So now engine connect. So now we have our connection. So we can test it by just saying, so with this connection now we can speak to the database and do a lot of things. So the next thing we are going to do is see how we can change these data sets into what we can put into the database. Then we will now put them into the database. So the next thing we want to do now is see how we can put the data into a format that Postgres can understand. But before we proceed, let's read the data in, all of the data. But depending on everybody's system, it might make your system hang and stop working. So but there is an option in pandas that allow you to read it in forms of iteration. So you can create an iterator and go in a particular size you want. So to do that, we'll read it again. But now we are going to provide iterator arguments to be true. Then we can choose chunk size. So let's say we want to do 100,000. So we want to be picking 100,000. So let me get the file name again. So now if you should check the variable, we have this object that we can now read one after the other. So a simple way to read it is just to put nests, and you have the first batch of 100,000 of the record. So if we do df add now, see we'll have record. So to finish, we have to go from the beginning to the end of the iterator. To do that, it is easier to do that using maybe a while through loop or a while loop. But for now, we are going to work on this 100,000, then we'll change it to a loop. So to create a table inside the database, we are going to use the columns. Each of the columns, the names, we are going to convert them to SQL and use it to check if there is anything of such. That is one. But let's check the attribute of this value. If you see, this is a datetime object, but it's seen as an object. That means it is a string. So maybe it would be best we first convert that into a proper datetime. So to do that, you can do pd to datetime, and you can now put that inside. Then we'll save it back inside. The same thing we do it for the second column, that is datetime. That is for the pickup and the drop-off time. So if we should check again now, we'll see that we now have it in form of datetime. I don't want to check the info. You can see we now have it in form of datetime, but we are not really a data analyst, so we will not perform any cleaning for that. So from here, let's try and create our table. So the first thing we'll do is to create our table from the column. Using add method, we get the first 10 by default, or first 5. But if you put 0, it gives you just the column. So this column, you can change it to SQL with that method. So with that SQL, it will generate, you have to pass the connection to it, then the name of the database you want to use. We can use the file name green trip data, so we can just say green trip data. Then for this to always check maybe that table is available before, what should happen? We can have an extra parameter and say if there's a table, it should just override it, because this is the first time we are putting any record into the table and it's just the head. So we have something here, name, connection, okay. So now it's telling us that we have 0 record. If we go to our pgadmin and our password is root, let's see it. So let's go to the database. Let's see, maybe it is there. We'll go to schemas, and under the tables, you can see we have green trip data. Then we can check for the first 100 row. You will see that it's only the table that is just created. There's nothing inside. The same method we use, we can use it to now add the remaining record to it. So we'll take all the records now, but we'll not use the add method. We'll just take everything, change it to SQL on the Postgres connection, the same, but we'll not use replace here. We have to use append. So if we should run it now, it might take some time to finish, so we'll have to wait a bit. So we are running 100,000 record currently. Imagine if we run it at the same time, it's going to give us it will be more slower. So we have 1,000 record. So let's check. Let's check. So we can view the first 100 row again. Okay. Let's run this from top. Select one. Okay, we have this. Then let's refresh and view data. So to check, we just needed to run a script and we can do select. So we can write anything we want. We can say select count, like from the screen trip data. Then we can just check. So we see we have the 1,000 rule we added. So that means let's see some of them. Let's select all the column and see what we have. Let's say we want to select all, and we want the first 20 record. See, we have the records now. We can see everything straight from there. That means our connection to the database is working, and we adjusted this to 1,000, so it's picking it and saving it into the database. So to do the iterator until it is finished, we can then we can put all of this into a loop. So we can do, after the first one, we can now do let's insert a column down below. Then we can do while true. We want it to first get the next one. Second thing is, from the next sets of record, convert these 2 columns to date time also. Then we don't need this part again because the table is already existing. So we just take this and put it in it. So for every run, we can actually print a statement saying new records added. So based on the chunk size, we can put other information, new 1000 records added and like. And if we want to go further, we can do time. We can do start time, and we say time, and we do the end time also. Then we can now find the difference. That is the, let me change this one to end time. So we can do end time minus the starts. After the first one, I would like to just break, so we'll just test. So let's rerun from above. Because we are using time, we have to import it. So let's run everything again and see what we have. Run all. What from time? So that works. It's added in that time. So let's check it again and see how many records we have now. Let's count all of them and see. So because we run it only 2 times, we have 2000 record. So we can increase that number, and at the end of the day, we have it. If we did not add this break, and let's say we change this to 10,000 record, then we can now run everything again and see how it's going to be printing. So you see it keeps adding, but we don't have to wait. By the end of the program, I will show the outcome I'm having on my system, then we can continue. So see you later. So after some minutes, it's ended with this error. This exception means that there's no more iteration in our iterator, so it has to stop. We can actually try to avoid that error by surrounding this with a try. Then we can put except that one. Then we can print something to show. Print all record imported or ingested. Anyone that suits you most. So I'm going to save this and run it again so that we will avoid that output that we are having. So again, I'll say when this has finished running. So instead of having the error now, we can see when the record has finished imported, we have what? All record imported or ingested, any English that suits you the most. So basically what we have done here is we use pandas to read the CSV file we downloaded. Then we did a basic data wrangling by just changing the data type to the proper date time instead of the string it was. Then we learn how to connect to the Postgres database we created with Docker Compose. We now learn how to convert our headers, our columns into a table in such a way that every time we restart this program, it actually deletes the table if it is existing before and puts this new set of data. Then we can now append all the records. So if we are using appending, it will not delete the record, or if we should use replace, anytime it sees the table before, it just deletes it and start afresh. So we look through all the records, change the timestamp, and what save each of the set of record the chunk size we are using into the database. So after this stage, the next thing is to convert this into a Python code that we can now set up with Docker that we can just run directly from the console. So if we do that, we can put it on the cloud, we can put it anywhere. Just by running it and passing in the necessary parameter, it will get the file we need, process this basic processing we are doing, and send it to the database. And with that, we can say that we have successfully completed a basic data engineer work. So the next thing is we'll convert this into a Python code, then we change it into a Docker format that we can reuse anytime. So, bye-bye. So now we have to try and convert this notebook into pure Python script, and we try to make it into a reusable format. So let's begin. The first thing is we need to create our Python file. Let's find, so let's create a new terminal and go back to our folder. So we have all this. We want to create a new Python file. Let's call it interesting.py. So from there, if we check our file, we have this file. So we just have to move the codes we need from this notebook inside there. So first, let's move all of the imports. We'll move them one after the other. We have another one here. Then the next thing is let's get all our variables that we need to reuse, and I'll just get it along with the connection also. So we are using all this variable. Let's add an extra one. the table we want to use, the table name. We use green drip data. So we can connect. Then the next thing we need to do is to read in the CSV. So that means we can use this, but this does not have the iterator. So let's use this other one. We can use this other one and put it here. So because this file name can change, we can also change it into a variable and just put it CSV path. So we need to download it and just put it in the folder or any place we put it and just pass the URL. So we have that. It will read every 10,000. We can make it 100,000 if we want it to use lesser iteration. Then we need to move in converting the column into the right one. Then creating our table. If it is existing, it will be replaced. Then for the first set that we have, we want to insert it into the database. Then we now write a loop within a try and catch statement to do this. So this will work fine, but we need to be able to make this dynamic. So we are going to use a library called argpass. This allows us to collect arguments from the command line, and we can just pass it without opening the file at all. So all of these arguments will now become dynamic. We can pass it from the command line. So to do that, let's do def main and pass an object that will have all our variables. Then we can move all this in. That means we can do, for here, we can do params dot user. Then this one, params dot pass. Instead of pass, we can use password because pass is a keyword. Then we can do param dot host, then params dot port, the database name, params dot database. Instead of database, we keep it to DB. Then we do params dot the table we want to save it into. Then params dot CSV path. That is the path that this CSV will be located. If we notice these two, we are not using them. So let's update it. Password. And for this table, it should be this and then this. Which one again? Do we have it somewhere? Yes, this. Then we are good. So if we run this now, we just need to find a way to get these params to hold all those value. So using the argpass, we can add that to be the beginning of our program. There's this pattern you can use in Python. This allows you to run everything here before the main. So basically, it's just checking if this is the main file we are running. It should do this first. If you are running this file not as a module, it should do this first before doing any other thing. Then we now call the function and put our params. So that means we need to be able to get these objects that we want to pass. So to use argpass, you can check the documentation. We need to create a passer. Then we now add each argument we want. Then we now pass the arguments. So we can just copy it from here and we can start. So we have this. We need passer. We don't need name. We can remove the name. We can remove this. So we can give it any description we want. Just say ingesting data into PG database. Right? So to add each argument, we can use this pattern, add arguments, and there are multiple parameters we can pass in, but we are mostly interested in just two, the argument name and the description. So you can say this is a page database user. Then we do for the password, the hosts. Then we do password, small p, the hosts. We need the ports. Then we need the DB, the database name. We need the table name, and we need CSV path. So we can update all of this database, password, hosts, port, database name, table that we want to use, then CSV path. So now to now process it, we need to use the last step, which is what we pass it with this. Then it becomes an object we can use. Well, we call it params, and we are good. So if we run this in command line, we've not imported this library, so we need to import argpass. So if we run this and pass all of these arguments in command line, it should just run and finish the process as far as everything is available. So we can improve the code by adding more try and catch. What if the file is not available or the database is not currently running? We can do all those. But the next thing we are going to do is we are going to convert this into the Dockerized version that we can just run at once and get the jobs done. So what we are going to try and do now is see how we can combine the Python scripts we have written with Docker in a different way so that when you just run it, it automatically run the scripts with the parameter that you pass through the bash and everything will run. To understand what we are going to do, we are going to first show what it means to do Docker run. If you want to start an image, you can easily do Docker run and you put the image name and you'll see the image come up. So this is a Python 3.9 image. You can do the normal thing you do in Python, like print any information you want, or just do the basic arithmetic and the like. But if you need to do something like importing a library, because the libraries are not available in these environments, you only run it for Python. So that's the only thing you have access to. But there is another way we can do it to have access to the library is through using a Docker file. So we are going to create a Docker file and configure something else. So inside the Docker file, you have different things that can go in it. But for now, what we are just going to put is where is the image we want. We want to use the Python image and we are looking for 3.9. Then we want to also install pandas. Then the last thing we need to do is what is our entry point? Where do we want when we start this container, where do we want it to start from? So we can just choose bash. So we go back to our console. Instead of just doing Docker run, we have to first build it and give it a name. So let's just give it maybe Python test. And maybe this is our first version. Then you say you want to run it in this current folder we have. So you see, it's building it. It's trying to install pandas for Python 3.9. So it's going. So after this first one, this is the first time I'm installing pandas for Python 3.9. So it's going to download it, install it. Then after it is successful, we can now run the container as we want. So when it's completed, we continue. I think my network is slow. After some minutes, it's finally installed. It's if you can follow the prompt, it has installed the pandas, and now we can try running this particular Docker file and see what we have. First, we did build, so now we have to do Docker run. Then we can now put the name that we gave it, which is Python test 001. So you can see it has changed to root at this phone number from my own PC. So from here now, I can do the Python interpreter, I can break it up. And if I try to import pandas now, we'll see that it's available as a library. So this is another way to do bring up images and run them to Docker. So this is the method we are going to use. We are going to set up all our dependency. If you remember, we need pandas, SQL, alchemy, scicog, and we need time. That time is already inside. So we are going to set it up to meet the requirements we need. Then we will run it along with our PG database. Then we'll connect both of them together. So let's set up the Docker file to meet our requirements. Then we'll run it again. So now we are going to update this file to meet our requirements. The first thing is we want to install pandas, SQL, alchemy, and scicog P2. Those are the basic one we need. But we are going to add another thing here. We need a work directory. That's where we want our container to start running from. Then also the entry, we don't want it to be bash again. We want it to be Python, and we want it to run our file. That is the file we converted the notebook into. Then because this file is available on our own system, we need to put it in the virtual environment, inside the Docker environment. So we have to add another thing, which is to copy the file into our working directory. Our working directory is app. So if we should build and rerun this now, it will install all of this and copy this file into our app directory. Then it will try and run it. If we should use entry point of bash, we can browse before we run it, but like this, it will just run it straight. So if we go back to our console and to be able to do it, we have to exit of that. Then we will rebuild it. So it's trying to install the remaining needed packages. also see it has created the work directory. Okay, so I think something happened to my network and we have to restart. So my network was very bad. I have to retry it multiple times just to switch some network. But this is actually what you should see when you run it. Just do all this, download, and you are good. The next thing now is to try and run it. So you will notice that the file actually ran, but the main problem is the code we wrote before. We have not passed all the variable needed. And also the database has not started. So the next thing we are going to do is start the PG database and make sure we can connect them together. The way to connect them together is we must start them on the same network. So Docker has another command for creating network. So you create a network and you give it a name. So let's quickly look that up. Docker creates network. So you can just create network and the network name. So what happened? So the actual command is Docker network create. Then we'll now give it the name we want. So I'm just giving it PG network. So it's saying I have that particular network before, so I can give it any name I want. Let's say green network, but I will use the PG network. So the next thing is to start our PG database. So there is already a generated code to start it. So to start it with the network we created, we can use this. So it's good to type it out in maybe your code editor or anything so that you see what you want to do. You just copy and paste if you need to change anything. So I'm going to run us through it. So we are trying to run Docker in an interactive mode. The image we want to run is progress 13. If you notice, it's similar to what we have in our Docker compose. Then the next thing is we are passing environmental variable of user, the password, and the name of the database we want. Also, we are still maintaining the persistency to create a volume that links to this data so that anytime we start it, all the data we have inside will still be there. So we are going to still use the same volume here. We are going to use this so that we keep it in the same place also. For me, I'm keeping it there. So it should be /v and I should have a backslash here. So we are good now. So this is the network we created. We are saying it should start Postgres on this network and you should give it this name, PG database. So if I should copy all of this and take it to the console and run it. So it's saying it is already in use. So let me stop it in any other place we might be using it. I think we started. So you can see we have it already 4 hours ago. So I can just come here and stop everything. You can do it also from the command line, but since there's a UI. So let's run it again. Let's clear everything and run it again. Okay. I think we are still doing that. We are still using. So I'll just wait so that everything clear out and try it again. So just to continue, we are going to change our name to just PGDB so that we can continue. Then I'm going to use this, copy it, and next thing is to run it in the command. So we are just changing this to DB. So you can see our database has started. So the next thing is to try and run the code while still connecting to this database. So to run the code, we need something like this. So basically, what we need to do is docker run. We are using the same network. The name we gave our environment is, let's open a new terminal. We gave it to run the environment now. The name we gave it is a Python test, if I'm not mistaken. We want to connect on this network. Our user is still root. Our database is pgtb, and we want this database. The table name should be green trip data. That's what we want to use. Then this table name, when we are setting up our code, the name we use is different. So let's quickly check that. We use table, not table name. So we are going to change this to table. Then we are not using URL, we are using CSV path. So we are just going to change that to CSV path. So because I am doing this locally, instead of me to download online, I just use the local file I have. So I copy this name and just use it directly instead of downloading. But if you want it to always get the data online, you use the URL, then you write your code to download the file. So like this, we have the variable saved inside this, and we can now run this. So let's try. So to run it, we have to remove all of this because that's what we call that. So come to our console in a new environment and try to run it. So I think we have an extra V here. So let's run it now. So it's trying to run and we can see it's running, but there's this error of this green data is missing. That is because we, in our configuration, we haven't copied it into, just like we did here. We have to repeat the same thing. We have to copy it into the working directory. We have to copy it into the working directory like that. Then because of what we just did now, we have to do a rebuild again. So we have to build. So let's just quickly like that. Docker build. We want it to build Python tests 01 in this place. I have a 2 column here instead of 1. So now we can run again. So Docker run the Python test user root. So we'll try running it again. And now it looks like it's taking longer than expected. So to test maybe this is working at all, we are going to open a pgadmin, and okay, we can see output now. So this means this has started working. New records are being added in, and it will just follow the process we used. So currently we are taking how many records? We are taking 100,000 records. So the output will be slower, and when it's just done, it's just random. So basically, to summarize, we tried to first learn how to use Docker Compose to start two containers together on the same network. We learn how to transform a CSV file into what PostgreSQL can understand. Then we now process it to have it persistently in the database. So this code, you can reuse it with different CSV. You can recode it to download data straight from the online repository. This is just a basic trial, and I hope you find it useful.